Hello friends, welcome to the channel of Digital Tutorial. Today I am going to discuss about the randomization methods which are available in system Verilog and which comes along with the randomize method. Okay, so for example, you see I have written a class packet. Okay. So the class packet semicolon rand bit 7 down to 0 ADDR semicolon, that is address semicolon, rand bit 7 down to 0 data semicolon, rand integer packet delay semicolon, constraint packet underscore delay. Packet delay greater than 1 semicolon, packet delay less than 20 semicolon. The constraint I have put for packet delay. Okay. This is the packet delay, constraint name is pkt underscore delay, and here is the end class. So this is the class definition. The system Verilog has randomized method to generate random values for all random variables of an object. So we will make the object of the class packet, and in the class packet address, data and packet delay, they are all of rand in nature. So when we will do the randomization, when we will call the randomization function, this particular variables will be randomized. Now module random underscore func underscore test semicolon. So here I am testing the randomization of the class object of packet. Initial begin end, inside initial begin end packet pkt semicolon. So I am making an object of the packet class and pkt is equal to new semicolon. Okay, here I am creating the packet class, object of the packet class. Here I am instantiating the object. Here I am creating it, and here pkt.randomize. So I am calling this function randomize, which is available in actually system Verilog LRM. Okay, so pkt.randomize semicolon and begins end, and here is the end module. So now randomize method returns 1. So this is a function actually. This is a function available in system Verilog LRM, and this function return 1 value or it can return a 0 value. So this random method return 1 if the randomization is successful, and if it is not successful, what it will return? It will return 0. The randomization successful means that it will assign the random values to all the rand or randc variables which are available in the class. So the randomize method is associated with two callbacks, that is pre-randomize and post-randomize. These are also two methods. Okay. So pre-randomize and post-randomize are methods which will get called before and after the randomize method respectively. Means pre-randomize and post-randomize, these two methods or these two functions are available with randomize function only. This pre-randomize, this will be called before randomize function will be called, and post-randomize will be called after randomize function will be called. Okay, please note that pre-randomize and post-randomize we will define in the class. But while calling, when we create the object with the new in the module, before we do the randomize, no, pre-randomize function or method will be automatically called, and even after randomize, no, post-randomize function will be automatically called. We need not to explicitly call them. Okay. As I said, this randomize function is available in system Verilog SVLRM, and this is the syntax of the randomize method which is available in system Verilog LRM. Virtual function int randomize semicolon. Why this virtual is used? Virtual keyword is used for the function so that in future when we make the child class of a particular class, we extend the class. So this randomize function can be overridden. Now let us see the pre-randomize method. So this function is defined within the same class whose object will be randomized and called before randomization. Okay. So how is the syntax of this particular function looks like? Function voice pre_underscore randomize bracket semicolon. Okay. Now I will show an example. For example, class packet, same set of random variable, address, data, packet delay. Okay, same constraint for the packet delay greater than 1, packet delay less than 20. Now I am defining this function voice pre-randomize. What I am doing? I am just putting a display here, $display. This will be called just before randomization, end function and end class. Okay, so when simulation will be run, first the object of the packet will be constructed by new function, then pre-randomize method of the class packet will be called, and then randomize method call happens. So it is like this: object creation, pre-randomize, and then randomize. Now we will see the post-randomization method. So this function is also defined with the same class whose object will be randomized and called after randomization. Wherever this pre-randomized function will be kept, whichever class, in the same class only post-randomized function also will come. Okay, so it is defined in the same class whose object will be randomized. So syntax of this post-randomize function is function voice post-randomize. Okay. Now I will show you an example how it is used. For example, class packet, same class, rand bit 7 down to 0, address semicolon, rand bit 7 down to 0, data semicolon, same rand integer packet delay semicolon, then constraint for the packet delay. Then same function void pre-randomize, $display, this will be called before randomization and end function. This is the pre-randomize. Now post-randomization will come. Now function voice post-randomize semicolon $display inside the function, and end function I have put. This will be called just after the randomization. So then end class for the class packet. Okay. So hope you are able to get little bit idea of pre-randomize and post-randomize functions and how they are called in the class, how they are defined. Okay. Now pre-randomized function can be used to set the precondition before the object randomization. So there is a particular role for the pre-randomization, randomize and post-randomize function also. So pre-randomized function is used in order to set some control logic for the randomization before the actual randomization happens. For example, user can implement randomization control logic in pre-randomized function. How we are going to implement the randomization control logic? For that we have a keyword available in system Verilog for randomization, that is rand_mode and bracket. Okay. This particular method, rand_mode method, is there to enable or disable the randomization of a particular rand or randc variable. Post-randomized function can be used to check and perform post conditions after object randomization. Suppose object has been randomized. Now I want to display the value of all the variables of the object. That thing you can do in post randomization. Even you can override the randomized value. You can make use of the randomized value obtained, and for the next packet creation, if we want to put some condition based on the present randomization value obtained, we can do so in the post randomized method. For example, suppose we have a packet and this packet has two variables, address and write read. Assume that when write read, this particular variable value is 0, then it is read operation. When this value is 1, that means a write operation. Now, in order to perform a write followed by reading to the same address, this is the condition. I will write to a particular address and I want to read back from the same address. So, in order to perform the write followed by reading the same address, randomization of the address is controlled based on the previous randomization value of write read. Means suppose certain value of write read, suppose I have got write read value 1. That means that is a write operation. I am writing, suppose for this write operation certain address is generated. Now for reading operation, for the next cycle when the next packet will be generated and I want to have the read operation where the write read value would be 0. At that case, no, the address would remain same. I will access the same address. So such type of condition, if I want to implement, no, I can make use of pre-randomize and post-randomize methods. Here is the class packet, rand bit 7 down to 0 address semicolon, rand C. Here is the cyclic, rand C. Cyclic randomization is happening. Rand C bit write underscore read semicolon. Bit temp underscore write underscore read semicolon. This is not randomized. This temp write underscore read. Another thing to be noted, why this write underscore read has been kept at rand C? Because and bit value it can take 0 and 1. So if in once first iteration if 0 has come, next iteration 0 cannot come for write read. It has to be 1. In the third iteration again either of write or read can come. Okay. First all the iteration or all the possible values for this bit, that is 0 and 1, will be generated for write read for the consecutive packet, and then for the third packet some other value will be generated. This is the cyclic characteristic of the rand C keyword. So now for pre-randomization function, I am going to have a pre-randomize function. Now I have put the comments for that. For pre-randomization function, what I will do? I will disable the randomization of the address if the previous operation is right. So if the previous operation happen to be right operation, then in that case I will disable the randomization of the address. Means in that case ADDRR, that rand, this particular mode I will set it to 0. Then this address won't get randomized. It will hold the old value only. So that is what has been done. Function void pre underscore randomize semicolon. If temp underscore write underscore read is equal to 1, ADDR dot rand mode 0 semicolon, else ADDR dot rand underscore mode 1 semicolon end function. You see, if temp write read happen to be 1, then this address rand mode would be 0. That means this address variable won't get randomized. If it is 0, then we will go to the else part of the statement, address underscore rand mode 1 semicolon and end function. So in that case the randomization will remain enabled. So this temp underscore write read, how we are getting the value 1 and how we are able to check it in pre-randomize, we are doing in the post-randomize method. Post-randomization function, store the write read value to temp write read value. So write read is actually a variable in the class packet, and display the randomized value of address and write read. Okay, here is the function void post-randomization semicolon definition. So temp underscore write read is equal to write read semicolon. The assignment will happen after the randomization will happen. No random value will get generated for address and write read. So write read value I will assign it to the temp underscore write read variable. And then I will call the display system task post randomization address is equal to %0h write read %0s. These are the format string, hexadecimal format. The address and write read would get displayed. Then inside the double quotes, then comma address comma write read bracket close semicolon and end function for the function and end class for the class packet. Now in the module rand underscore method semicolon. In the module, actually I am creating the packets. You see, initial begin, inside the initial begin end, what I will first create the packet, create the object of packet, semicolon. Packet I am doing new. Okay, now repeat for packet dot randomize semicolon. So repeat for means packet dot randomize will be called, this method will be called repeatedly 4 times. So first pre-randomize, randomize, post-randomize, first iteration, second iteration, what it would be again, pre-randomize, randomize, post-randomize, pre-randomize, randomize, post-randomize. This way it would be 4 times, module and end module. So when we will do so, no, what we will do, we will display the values of post randomization value of write and read, write, read and address. Okay, and also the assignment of the post randomization will happen into temp write read, and that would be used in the pre-randomized particular method in order to enable or disable the randomization of the variable address. So hope this randomization methods are clear to you. Hope I am able to make you understand little bit on this topic. If you like the video, share with your friends. Please subscribe the channel and have a very nice day. Bye bye.